Hello to everyone and welcome to a new Energy Capital interview. I'm Anna and today we'll be talking with Megan O'Connor, co-founder and CEO of Nth Cycle. Megan, it's great to see you today. How are you?
Yes, thank you so much for having me. I'm great. I'm happy to be here.
That's great to hear, Megan. In this interview, we will talk with Megan about the environmental challenges of developing clean energy and the potentialities of electro-extraction in helping mining companies and battery recyclers avoid dirty processes in their manufacturing. So, Megan, I'll start with our first question. To start, what are some of the environmental challenges of developing clean energy, and what is the importance of acknowledging these challenges?
Yeah, that's a great question. Thank you. So I think a lot of the environmental challenges of developing this clean energy economy that we're all really striving for is really taking it all the way back to sort of the building blocks or the metals that power all of these clean energy devices, whether it's an EV or a wind turbine. They all rely on these critical metals. So you can think of cobalt, nickel, and lithium are the main metals in lithium-ion batteries. And then if you think about wind turbines, they have really large magnets that help power them, and those have critical metals called rare earth metals. And all of these materials come out of the ground, and there's very hazardous, dirty processes that we currently use to pull those out that then go into manufacturing. And so what we're really trying to do and trying to bring awareness to the space is there are better alternative methods to pulling these building blocks, as we like to call them, out of the earth so that we can have a truly clean economy instead of building out this wonderful economy and with all these technologies and still having these dirty processes. We can do both, right? And that's why one of our slogans is a sustainable path to a sustainable planet.
In this regard, Megan, compared to other regions, how can North America competitively recover critical materials in sustainable and cost-efficient ways?
Yeah, so we have all of the raw materials here within North America to get to the demand that we expect in 2030. We just need, again, better methods to do that. So we could become very cost competitive and competitive in the market space in the clean energy sector, again, with new technologies that can operate within the environmental regulations that we have here in North America. And again, that's really where new technology like electro-extraction can come in, is a much more sustainable, cost-effective way to pull these materials out instead of using all the harsh acids and solvents that you'd see with the traditional technologies. Thinking about a different way to pull these out with like electricity, which can come from 100% renewable, it makes it a much cheaper and more efficient way to mine these materials that we have here. We just currently can't tap them.
So specifically, how is Nth Cycle's electro-extraction process helping battery recyclers reduce the environmental footprint of their activities?
So in lithium-ion batteries in particular is such a novel type of waste, right? This is not a waste that we've been dealing with for 100 years or so, right? It's relatively new in the space of waste management. And the main issue with lithium-ion batteries in particular is that it's very hazardous to transport these materials, right? We all have seen the videos of these batteries spontaneously combusting when they're on airplanes or even on people's bedside tables. And so you can imagine once they reach their end of life and they have defects and whatnot, shipping them all to one centralized facility is very dangerous, right? With them in the back of a truck, jostling around. You can imagine all of the issues that we've seen in terms of safety. And so we've really had to think about how do we change the model and change the way the recycling industry thinks of this waste, right? Instead of having to collect all the waste and ship it to one centralized facility, Nth Cycle really thought about, okay, this is a decentralized form of waste. The most expensive hazardous part is actually shipping it. And so what if we'd created a modular technology that was not only cost effective, but also much more sustainable so that it can be applied to other industries like mining, to decentralize this waste management problem. So we actually can go on site and recycle the batteries where they are instead of having to ship them all to one centralized facility. So that not only saves us a significant cost on just the safety requirements to ship these batteries, but also then has the cost savings on top of that with completely changing the way we chemically process the materials back into the materials that go into manufacturing.
Megan, you already talked about decentralizing the transportation or the shipping of these batteries, and particularly how can this process benefit mining companies? But we would like to ask you, how is electro-extraction also helping mining companies reduce the scale of their tailing ponds, also minimize transportation needs, and particularly energy use and reduce on-site risks?
Yeah, great question. So the real benefit of Nth Cycle, in addition to the modularity and being able to decentralize sort of this waste management issue I mentioned before, is really in the way we process materials. So electro-extraction is completely different in terms of the recycling processes or mining processes out there today, which are called hydro and pyrometallurgy, which use very high temperatures or pressures in terms of pyro, or lots of acids and solvents like in hydrometallurgy. Electro-extraction uses the only input is a low amount of electricity that can come from 100% renewable. And so that's really where we get the large cost savings and the large reduction in our carbon footprint. Again, because we don't have to push all those harsh acids or solvents or use dirty furnaces to really pull the valuable materials out of the tailings ponds or the raw ore that we'd see on all these various sites across the US and Canada.
And finally, Megan, last but not least, how does Nth Cycle's electro-extraction help clean energy companies avoid dirty processes in their manufacturing?
Yeah, so we can see ourselves implementing the technology across the whole supply chain, right? It's not just one area that needs help, right? Even if we were able to recycle 100% of the material in 2030, it would only be a fraction of the demand of the materials we'll need for the manufacturing of all of these new clean energy technologies. And so Nth Cycle's mission, right, is really to deploy this technology in every area that we can to truly sustainably extract the raw materials that we need to become truly metals independent, as we like to call it, so we don't have to rely on overseas supply chains anymore, so that these manufacturers know where their material is coming from and know exactly the carbon impact that it has, which can be significantly reduced, again, using a technology like Nth Cycle's versus the mining processes that are used out there today. And so we're hoping that, this can translate up through the value chain so that manufacturers can inherently have a much lower carbon footprint material, knowing that they're using a much lower carbon footprint starting material.
Well, Megan, thank you very much for sharing this important notes with us and for all the work Nth Cycle is developing to help several companies, including energy companies, in this energy transition. So in this sense, would you like to share a final message with our audience?
I'd just like to say, we're working on one very small part of this. And so we're very excited to be a part of this industry. Like I said, I think there's many places along the supply chain that need, to be fixed or to be enhanced to truly create a circular economy. And so, I encourage all of you working on similar technologies in different parts of the supply chain to keep going, because I think this is a really big issue and I'm excited to be one part of it.